Hello Math 3A, welcome back to some problem set examples. This first page on the problem set is mostly about U substitution, so I'm going to do some examples like that. The first one right here, like the first one on the problem set, is pretty straightforward. So in general, you try letting U equal what is the inner function. So that's going to be the 1 minus x squared. So let the U be the 1 minus x squared, and then take the derivative of that. So the derivative is going to be negative 2x. Now over here, technically I should put du over dx and then multiply both sides to transfer the dx over here. But to save a little bit of time, I just do that as one step. Now if you look at the original problem, this is going to be replaced with u, so we're done with that. Also, there's an x times a dx. And in my u substitution setup, I also have x times dx. But they don't have a negative 2. So I'm going to have to get rid of this negative 2. So divide both sides by negative 2, or multiply both sides by a negative 1/2. And now this has x dx, and this has x dx. So now it's ready for the u substitution. So this is going to become the integral, and then this is going to be the square root of u. And now replacing the x times dx, we have negative 1/2 du. So this negative 1/2, I can actually just factor that out and then put the du right here. Okay, the next thing to do is I can rewrite the square root as u to the 1/2, and the rest of this stuff stays here for now. And now to find the antiderivative. So you can just add 1 to the exponent. That's going to be 1/2, or in other words 3/2. And then divide by 3/2. So when you divide by a fraction, you can simplify that by saying multiply by the reciprocal. So I already had a negative 1/2, and now multiply by the reciprocal, so that's going to be a 2/3. And then the u is going to be to the 3/2 power. And now that we're done finding the antiderivative, I do need to put the constant of integration, so plus c. And then the final step is the original question had x's, so the answer should have x's. So I need to replace the u with the 1 minus x squared. I can also do a little bit of canceling right here, have those 2's cancel. So there's going to be negative 1/3, and then replace the u with 1 minus x squared. And then that's to the 3/2 plus a c, and this one is finished. Now, number 2 is going to look very similar to number 1. So on number 2, I just took off the squared from that little x right there. And that is going to change the work a little bit. So let's do that. So again, let u be what's inside of the square root. So let u equal a 1 minus x. And then take the derivative. So the derivative will equal just a negative 1 times dx. So this does not have a negative 1 dx, so I can take this negative and transfer it to the other side. And then it's just going to say dx on the right side. So I know what to replace the dx with. That's going to be the negative du. I know what to replace 1 minus x inside the square root with, but then there's an extra x right here. And when you have an extra x, then what you do is just go to this line and find out what x equals. So I could take the negative x, move it to this side so it becomes positive x. and then take the u, move it to this side so that x equals 1 minus u. So now I know what to replace x with, a 1 minus u. And this is going to replace what's inside the square root. And then in place of dx, we just use negative du. So that's going to be integral. So this first x becomes the 1 minus u. Then there's the square root of u. And then at the end, replacing the dx is going to be this negative du. And I'm just going to put the negative and factor it out. So like with the last one, I would rewrite this as x to the 1/2 power. I think I just said x. I meant to say u to the 1/2 power. And then the difference with this one is we need to do a little bit of algebra, and that is distribute before we integrate. So the negative sign can stay on the outside, and then it's going to be u to the 1/2 times 1. And then this is a u, and another half is 1/2. And that is also known as 3/2. All right, now we've done the hard part. Now for the easy part. Add 1 to the exponent, that's 3/2, and divide by 3/2. Go to the next one, add 1 to the exponent, that's 5/2, and divide by 5/2. And then we're almost done. So this will be inverted, so this is going to become a 2/3, and the negative applies to everything. Then we would have 2/3 u to the 3/2 minus, and then invert this one, it will become 2/5 u to the 5/2. Now that we're done integrating, put the plus c. And the very last thing is go back and replace the u with 1 minus x. So I think I'm also going to distribute this negative. So negative 2/3, and then replace the u with 1 minus x, and that's to the 3/2 power. And then negative negative is positive 2/5, and then replace this u, so it's 1 minus x to the 5/2, and then the plus c. And there we are, finished with number 2. What about number 3, you might be saying? And I would say, good idea. So if you're looking at the actual problem set, I was thinking of this one. But of course I can't do it with sine and cosine, because then I'd be doing your homework for you. But I could do it with something similar. So with this one, let me get an extra piece of paper. So with this one, sometimes when you do u substitution and you go, all right, let u equal, and they say you should let it equal the bottom of the fraction, 1 plus e to the 2x. And now take the derivative of that. So the derivative, well, the derivative of 1, 0. The derivative of the e function is the e function. Then we need to do the chain rule. The derivative of 2x is 2. And then, like I said earlier, this would start off by saying du dx, then transfer the x over to this side. So all the x information is on this side, all the u information is on this side. Now the problem is that this says e to the 2x times dx. The 2 doesn't really matter because I could just divide by 2 or multiply by 1/2. But this says e to the 2x times dx, and this says e to the x times dx, which means that's why I got an extra piece of paper. Sometimes that happens with u substitution. You try something, it doesn't work, and you say, okay, let's try something else. Well, the something else with this is you could rethink this part. E to the 2x is the same thing as saying e to the x being squared. because when you have a power raised to a power, you multiply them, and then that is the same thing. So with this one, the first thing I'm going to do is rewrite it that way. So it's really e to the x on top, and then 1 plus parentheses, e to the x is being squared for the bottom. So when I let u equal the whole thing, that didn't work out. But right here, we have an e function that's inside of a squared function. So the u should be this little e right here. Once again, u substitution, sometimes you have to try it and see if it actually works. So I'm going to try it. And now take the derivative. So the derivative of e to the x is e to the x. And then multiply both sides by dx. And now this is exactly what this says. So this u substitution deserves a smiley face. It's going to work. So on the top, the e to the x times dx is the same thing as this, so it gets replaced with just du. And then this is going to be 1 plus, and this will be u being squared. And then, because you remember the derivatives of trig functions and inverse trig functions, you would look at this and say, oh, this comes from somebody took the derivative of tangent inverse. So this one is tangent inverse of u plus a c. And like always, then replace the u with the e to the x. So then it's going to be tangent inverse of e to the x plus a c. And then it's done, and it even deserves a red check mark. That is correct. And you too, smiley face, you get a check mark. And let's see what comes next. Well, if that's number 3, it must be number 4 that's coming up next. And this is meant to be an easy problem. But if you try u substitution on it, it's not going to work. Because if you do u substitution, then you should try letting u equal to x squared. And the derivative of x squared is a 2x. And a 2x has no plus 5 in it. So it's this plus 5 that is preventing us from using the u substitution. So instead, what you do is use algebra and say, you know what? I'll bet somebody had 2 fractions. Each of them had the common denominator x squared. One fraction had x on top and the other one had 5, and then they added these together to get that. Or the other way to look at it is, this is saying x plus 5 gets divided by an x squared, which means that each one gets divided by an x squared. And then I could simplify this one because this is just 1 over x. And then to integrate this one, I would rewrite it as 5 and then x to the negative 2. And this one, I just leave it like that because I know that that one comes from the natural log of x. And for the other one, I could just add 1 to the exponent, which is a negative 1, and then divide by negative 1. So that's going to leave a negative 5. And then this will be x to the negative 1, and then put a plus c. Now technically it would be fine to leave it like that, but because I'm allergic to negative exponents, I'm going to rewrite it like this. And just not leave a negative exponent, just rewrite it as the negative 5 over x. And then one more with integration and u substitution. So if you're paying attention to number 3, I basically had 1 plus the e function being squared. And then I let the u equal that e function. If I try that here and I say, well, okay, inside of this square function, there's a cosine. So I'm going to let u equal cosine of x. Then take the derivative of that, and the derivative of cosine is negative sine x dx. And you go, look, it worked. Except not quite, because that's got a 2x. And this does not have a 2x. And on this line, when you're trying to adjust it to make it look like this, the only thing you can do is multiply by a constant, divide by a constant, and that's it. So there's nothing we can do about this because that says sine x and that says sine of 2x, and those are two different creatures. So this u substitution doesn't work. So pick another. So the next thing I would try is let u equal the whole bottom part. So let u equal the 1 plus the cosine being squared. And now take the derivative. So the derivative of 1 is 0. Over here, use the power rule, so the 2 is going to go in front first, and then subtract 1. And then do the chain rule. Now take the derivative of cosine, which is negative sine of x, and then multiply both sides, so it says dx. And then you say, but Mr. Perkins, buddy, this is not even close to sine of 2x. And I would say, yeah, well, but if you think about a trig identity for sine of 2x, the trig identity for sine of 2x is that it equals 2 times sine of x times cosine of x. And if you look at what we have here, we have the 2, we have the sine x, we have the cosine x. All we do is have an extra little negative right there. So if I just get rid of that negative and I use this trig identity, then it's going to work. So just multiply both sides by a negative. And then I'm just going to rewrite this in the same order. So multiplication, you can change the order. And then because the top is equal to 2 sine of x times cosine of x, that means that all of this whole thing gets replaced with just negative du. So one of the other great things about u substitution, you take something that's more complicated and you replace it with something simpler. So this one is going to become integrate, and then this whole thing, or this whole thing, gets replaced with just negative du, and I'm going to put the negative on the outside. And then on the bottom, the u is equal to the whole thing, so it's just du over u. So it took something that's more complicated and definitely made it simpler. And then this is just like 1 over u, so that means that the answer is natural log of u plus a constant. And, like always, replace the u with 1 plus the cosine squared. And then plus c. And then this one is so lovely, I'm even going to make a nice box around it. All right, then when you look on the second page of the problem set, it's going to ask about area and things like that. So if you have this function, so this is an upside down parabola, you might need to, in here I just went ahead and put what the limits are, but if you need to, you might need to set it equal to 0. And then either use the quadratic formula or factoring. I'm going to factor out an x. And then set this equal to 0. Set this one equal to 0. And then that's where I got the limits 0 to 1. So find the area. Oh, I forgot to write the rest of the sentence. Between f of x and the x-axis. So that's basically saying, all right, you've got this parabola that hits the x-axis at 0 and 1, and then find this area. So that's pretty straightforward. Just integrate from 0 to 1. So integrate from 0 to 1, the negative x squared plus x and then do the antiderivative, so negative x cubed over 3. For this one, its exponent is 1, so when you add 1, it's going to be x to the 2 over 2. And then evaluate from 0 to 1. So when you substitute a 1 in there, this is just going to be negative 1/3. And this is going to be plus a half. And then when you substitute 0, that's going to be 0 and that's going to be 0. So finally it is negative 1/3 plus a half. And then that is going to be hold on, that's too bright. Let me take down the contrast or the brightness. Okay, right about there. Okay, so first of all, that would be a negative 1/3 and then plus a half. So that equals a 0.167. Or if you want to look even smarter, then change it to a fraction, or 1/6. And then I also did graph it, so y equals x squared plus x is the original problem. And then change the window to go from 0 to 1. And 0 to 1 on the y-axis should be good enough to see. So as you can see, it looks exactly like my picture right here. And then to check the answer, I can say second calculate number 7 and then go from 0 to 1. And hopefully you could see it right there. It says the answer is 0.167. So we get check marks on this one. Okay, but that's not all, because as you can see, okay, now, as you can see, that's part A. What about part B? Good question. So part B is going to take the same area and then find volume if this region is rotated about the x-axis. So basically you take this picture right here from 0 to 1 and then you spin it around the x-axis. So spin it around and around and around, and it would make something that looks sort of like a basketball, except if you look at this graph, it would be more like an elliptical type basketball. Then again, this isn't really to scale. Okay, now I'm going in the weeds. So anyway, if you take that region and rotate it around, it would make a three-dimensional object. And so when you're rotating around the x-axis, then it's going to be the integral of pi, and then the function gets squared. So basically I'm doing pi r squared. So area equals pi r squared. And so when you do pi r squared, that gives you area. If you then say times another dx, then this is an area times, so this would be in square feet, area would be in square feet, times another feet is now cubic feet, so this is volume. And then this is going to go from 0 to 1 like the other one. And I said pi r squared, but I didn't write the squared. All right, so that means that when we actually go to do the work for this one, we need to do some algebra first. So this pi could be factored out so that it doesn't get injured while I do this algebra. And then square a binomial. So that means you need to square the first thing. And when you square that negative, it's going to be positive. And then it's going to be x to the fourth. Then for the middle term, you multiply these two, which will be negative x cubed, and then double that result. So negative 2 x cubed. And then you square the last term, x squared. All right, now just go through and add 1 to the exponent. So this is going to be x to the 5 over 5. Add 1 to the exponent, so I can't forget about the 2. So this is going to become x to the 4 over 4. And then add 1 to the exponent will become x to the 3 over 3. And then don't forget paito right here. And also, it's going to be from 0 to 1. And then this is where I really love the number 0. Because when I put a 0 in, that's going to be 0, that's going to be 0, that's going to be 0. It cuts my work in half. Thank you, 0. I just need to substitute the 1. So there's the little pi. And then when you substitute 1, this will be 1/5 minus, this will be 2/4, but that's also known as a half. And then a third. So how much is a fifth minus a half plus a third? So 1/5 minus 1/2 plus 1/3. And then to make me look smart, I'll put a fraction, and that's 1/30. So that's why I was saying this is paito, because it's 1/30 of pi. And then just real quick, in case you want a decimal, you can just say pi divided by 30. So it turns out that it's just a 0.105. And then whatever the units are, because this is volume, it would be cubic units.